Long before the first word was ever written, ancient eyes were tracking the stars with a precision that defies explanation. This video reveals how prehistoric cultures, without any written language, mastered the cosmos with knowledge that often rivals our own modern understanding. You will discover the true intellectual heritage of humanity, a story that completely rewrites our past. How could hunter-gatherers build a temple aligned to a star not due for prominence for 13,000 years? What forgotten science allowed Pacific navigators to cross an ocean using only the night sky as their map? What does it mean to truly understand our place in the universe? In the quiet hills of Scotland, an archaeologist of the 19th century made a discovery that would quietly upend our understanding of prehistory. He was studying a simple stone circle, a relic assumed to be a crude calendar aligned with the sun or moon. But his measurements revealed something far more profound. The stones were not pointing to any celestial body visible in his era. Instead, they were precisely aligned with a star whose slow, grand dance through the heavens would not bring it into that specific alignment for another 13,000 years. This was not a mistake. It was a message across time, a deliberate marker set by people we have long considered primitive. How could a culture, one without any form of writing that we recognize, plan for a celestial event so far in the future? This is the central enigma of prehistoric astronomy. It forces us to confront a simple, staggering fact. Ancient peoples did not merely glance at the night sky. They studied it with a scientific rigor we are only beginning to comprehend. This field of study, known as archaeoastronomy, deciphers these ancient alignments. It is the science of reading the stars in stone, of listening to the whispers of the past encoded in monuments. The work of archaeoastronomers consistently reveals a depth of knowledge that challenges the conventional, linear timeline of human progress. We are not looking at lucky guesses or simple patterns. We are looking at the results of meticulous, long-term observation, the kind that requires generations of dedicated sky watchers faithfully passing down their knowledge. The pressing question is no longer if they observed the stars, but how they achieved such impossible precision without the tools we consider essential. This points to a forgotten epoch of inquiry, a long, silent age where humanity's first scientists mapped the cosmos with nothing but their eyes, their minds, and a patience we can scarcely imagine. The stone circles of Scotland pose a profound question, but an answer may lie much further south, in the sun-baked hills of modern Turkey. Here stands Göbekli Tepe, the world's oldest known temple complex. Its massive, T-shaped pillars were raised over 11,000 years ago by people who lived as hunter-gatherers. For decades, the intricate carvings of scorpions, foxes, and vultures were seen as powerful spiritual symbols. But a radical new interpretation suggests these animals are something far more precise. They are constellations. The very layout of the stone enclosures appears to be a mirror of the night sky, aligned with the rising of stars like Sirius. This is not random decoration. It is a sophisticated celestial map carved in stone. Groundbreaking research, such as that by Dr. Martin Sweatman, points to one pillar in particular, the so-called vulture stone. Its complex imagery, including a vulture and a scorpion, may not just represent stars but record a specific, catastrophic event. The theory proposes the carvings commemorate a devastating comet impact around 10,950 before the Common Era. This would mean the builders of Göbekli Tepe were not only master astronomers but also historians, encoding a world-changing event into their sacred architecture to warn or inform future generations. The sheer sophistication of this place forces a complete re-evaluation of pre-agricultural societies. How could hunter-gatherers, whom we often picture as living hand-to-mouth, dedicate the immense resources and coordinated labor required to build such a monument? The answer may be written in the stars. Their survival, their very understanding of the world's cycles and potential dangers, might have depended on this stellar knowledge. Göbekli Tepe challenges the very core of our historical narrative, suggesting that the drive to comprehend the cosmos is not a product of civilization, but its very foundation. This was a society that looked to the heavens not for myth, but for meaning, building a legacy in stone that would outlast millennia. The scale of this prehistoric knowledge becomes truly breathtaking when we leave the temples of Turkey and journey to the wild, windswept islands of Orkney off the coast of Scotland. Here, a vast ritual landscape emerges from the peat and heather, centered on sites like the Ness of Brodgar and the towering stones of Stenness. These are not isolated monuments. They are pieces of a grand, interconnected design, one repeated in hundreds of stone circles scattered across the European continent, and they reveal a secret. The builders of these sites were not just observing the moon, they were predicting its most complex dance with stunning precision. They understood the lunar standstill, a subtle 18.6-year cycle where the moon reaches the very extremes of its rising and setting points on the horizon. To track this cycle requires generations of patient observation, a commitment to a science that unfolds slower than a single human lifetime. How could such a long-term project be sustained? The answer may lie in a shared language of measurement. In the mid-20th century, an engineer named Alexander Thom surveyed hundreds of these sites and made a remarkable claim. He proposed that the builders used a standardized unit of measure, which he called the megalithic yard. From one circle to the next, separated by vast distances, the same mathematical proportions appeared. This was not random construction. It implies a shared, continent-wide system of knowledge, a pan-European intellectual tradition where information was exchanged and a common understanding of geometry and astronomy was applied. These stones were more than places of ceremony. They were permanent observatories, their alignments and shapes encoding celestial patterns into the very landscape. A circle might mark the midsummer sunrise, while a specific outlier stone pointed to the moon's most extreme northern setting, an event that only happens once every 18.6 years. They built a calendar in stone, one that tracked time with an accuracy we would find impressive even today. This was a testament to a collective mind, a civilization of megalithic engineers who looked to the heavens and saw not chaos, but a perfect, predictable order they could capture in geometry. But the megalithic calendar of Europe was not the only ancient system for reading the heavens. Far to the south, in what is now the vast emptiness of the Sahara, a different kind of celestial record was being made. This was a world of rock and sand, but it was not always so. Thousands of years ago, this region was a green savanna, a lush paradise teeming with life. Here, pastoral peoples created one of the most extensive art galleries of the ancient world on the Tassili Ennaja Plateau in Algeria. Their canvases were the cave walls, and their subjects were the animals of their world, great giraffes and herds of cattle. Yet among these earthly scenes, something else appears, something that speaks of a gaze turned upward. These artists painted the stars. We see precise representations of constellations we still recognize today, like Orion and the Pleiades, dated to over 7,000 years ago. This was more than simple decoration. It was a celestial map, a permanent record of the night sky created by people deeply connected to the cosmos. Some of the most intriguing figures from what is called the Roundhead period show human forms with bodies covered in dots. These dotted patterns do not seem random. They mirror the arrangements of specific star clusters, suggesting a profound, shamanistic link between the heavens and the individual. The sky was not a distant, cold void. It was a living tapestry intimately connected to life on the ground, to ceremony, and to identity. For these early Saharan cultures, the stars were a practical tool for survival. As their green world slowly began to wither, as the climate shifted and the savanna turned to desert, their knowledge of the constellations became a critical form of navigation. The familiar patterns in the night sky offered a constant and unchanging guide through a transforming and increasingly hostile landscape. Their art tells a poignant story of adaptation, a testament to human resilience. They mapped their cosmos on stone as their earthly home changed around them, ensuring that their guide to the heavens would endure long after the grasslands were gone. Across the Atlantic, another civilization was building its own vision of the cosmos from the Earth itself. In the fertile floodplain of the Mississippi River, the great city of Cahokia arose, a metropolis that at its peak around the year 1050 of the Common Era rivaled London in size. At its heart stood Monk's Mound, a colossal earthen pyramid towering 100 feet high, the largest prehistoric earthwork in the Americas. Its grand front plaza was not oriented randomly. It was precisely aligned to the maximum northern rising point of the moon, a celestial event on an 18.6-year cycle. This was not a solitary monument. Surrounding it were vast plazas and a series of what archaeologists call wood henges, great circles of massive cedar posts that functioned as sophisticated calendars. On the solstices and equinoxes, the sunrise would align perfectly with specific posts, marking the turning of the seasons with unwavering accuracy. This entire urban landscape was a physical model of a celestial order. According to the research of Dr. Tim Pauketat, the explosive rise of Cahokia was likely fueled by a powerful new cosmology, a celestial religion that organized every aspect of life. A central figure in this belief system was a morning star deity, often associated with the planet Venus. This brilliant wanderer appearing in the dawn sky may have been seen as a powerful warrior or creator figure, its cycles dictating the timing of ceremonies, warfare, and governance. The city's layout was a mirror of the heavens, governing agriculture, social hierarchy, and spiritual life in one unified system. The farmers who tilled the fields knew when to plant by the stars their leaders observed. The ceremonies that united the community were scheduled by the cosmic clock encoded in the wood henges. Cahokia represents a profound truth. These earthworks were not just buildings. They were a covenant with the sky, a way of bringing the perceived order of the cosmos down to Earth to structure human society. It was a civilization literally built upon a foundation of astronomical wisdom, a testament to the universal human drive to find our place within the grand celestial dance. While the earthworks of Cahokia mapped the cosmos onto the land, another civilization learned to read the sky as a map for the open ocean. The Polynesian voyagers embarked on journeys of staggering ambition across the Pacific, a realm of water so vast it covers a third of our planet. They sailed in double-hulled canoes, vessels lashed together with coconut fiber, carrying entire communities into the unknown with no instruments to guide them. Their survival depended on an art called wayfinding, a science of memory and observation passed down through sacred chants. At its heart was a mental star compass, a celestial map dividing the horizon into 32 houses. Each house was the domain of a specific star, a point of light that would reliably rise and set from that exact location. The navigator, sitting in the open hull, would know their direction not by a magnetic needle, but by the steady, predictable dance of these celestial guides. They lived by the stars, but their knowledge did not stop there. They read the ocean itself, memorizing the patterns of swells as they reflected off distant, unseen islands. They watched the flight paths of specific seabirds, knowing that a certain species would always return to land at dusk. For the final, most precise leg of a journey, they used zenith stars. These are stars that pass directly overhead at a specific latitude. By memorizing which stars stood at the zenith over their home island and which marked their destination, a navigator could sail north or south until the correct star was directly above them, then turn to follow that latitude west or east. This was not accidental island hopping. It was intentional, repeatable navigation. The settlement of far-flung islands like Hawaii and Rapa Nui was a deliberate act of colonization, guided by a sophisticated system of knowledge. In the 20th century, this ancestral wisdom was in danger of being lost forever, until a master navigator from a small Micronesian island named Maupiailuk made a courageous decision. He broke with tradition and shared his sacred knowledge with outsiders, teaming up with the Polynesian Voyaging Society to build and sail the Hōkūleʻa, a replica of a traditional voyaging canoe. In 1976, without a compass, sextant, or any modern device, Mau used only the stars, the swells, and the birds to guide the Hōkūleʻa on a 30-day, 2,500-mile voyage from Hawaii to Tahiti. He proved to a skeptical world that his ancestors were not drifters, but the greatest explorers in human history. Their story forces us to reconsider the very nature of knowledge, a system not written on paper or carved in stone, but carried in the living memory of a navigator, singing the star paths of his people under a canopy of endless sky. The vast ocean that separated the Polynesian navigators from the rest of the world seems to tell a story of isolation. Yet, when we look upward, a different narrative emerges, one written in a universal language. Why is it that cultures separated by immense oceans and thousands of years all saw a great bear in the same 7 stars, or a mighty hunter in the brilliant belt of Orion? This is far more than simple coincidence. It is a powerful clue to a shared human cognitive process, a fundamental way our brains impose order on the brilliant chaos of the night sky. We are wired for pattern recognition, and the stars provided the ultimate canvas. The specific stories attached to these patterns would drift and change, a process we might call constellation drift. The same stars that were the Great Bear to the Greeks might be a giant bison to the Lakota Sioux, or a group of wise ancestral men to Aboriginal Australians. The myths woven around the stars were as diverse as humanity itself, but the core asterisms, the recognizable shapes, remained stubbornly consistent. This points to a deep, prehistorical connection in how human minds, regardless of their location on the globe, process the cosmos. It suggests a unifying thread in our intellectual heritage, a silent conversation across millennia where different cultures looked up and, in their own unique ways, charted the same familiar faces in the heavens. This shared celestial vocabulary hints that our earliest ancestors, long before they built permanent settlements, were already sharing a common way of seeing, a foundational step in humanity's collective journey to understand its place in the universe. This universal human instinct to find patterns in the stars reveals our deepest cognitive wiring, but it also presents a profound challenge for modern science. The human brain is a pattern recognition engine, so adept at finding connections that it often sees them where none exist, a phenomenon known as apophenia. This is the central hurdle for the field of archaeoastronomy. How can we be sure that an alignment between a stone and a star is a deliberate act of ancient genius and not just a lucky coincidence? The history of this discipline is littered with grand theories that collapsed under closer scrutiny. One of the most famous examples is the so-called Leo correlation theory for the Giza pyramids, which proposed that the three Great Pyramids were laid out to mirror the stars in Orion's belt. While a captivating idea, the alignment is not perfect, and most Egyptologists point to a complete lack of supporting texts or artistic evidence within the ancient Egyptian worldview. The correlation is often dismissed as a modern imposition, a pattern we want to see rather than one the builders intentionally created. To overcome this inherent bias, modern archaeoastronomers have turned to rigorous statistical methods. The question is no longer simply whether a single alignment looks convincing. Instead, researchers use computer models to test a site's orientation against thousands of randomly generated alignments. They ask a simple, powerful question: what is the probability that this precise arrangement could have occurred by pure chance? Only when the odds are overwhelmingly against randomness, when an alignment is statistically significant, does it become a credible candidate for intentional design. But a single statistical finding is rarely enough. The true strength of a celestial interpretation rests on finding multiple, independent lines of evidence converging on the same conclusion. This is the scientific triage that separates compelling discoveries from mere speculation. A convincing case is built like a court case, relying on a preponderance of evidence from different sources. The architectural alignment itself is the first piece of data. Then, researchers look for corroboration in the artistic record. Do carvings or paintings at the site depict specific constellations or celestial events? Finally, they turn to ethnography, studying the myths, oral histories, and ceremonial practices of the descendant cultures. When a star's rising point marked by a monument is also described in an ancient story as the time for planting, and is depicted in art as a specific animal spirit, the case becomes powerful. This multidisciplinary approach transforms a curious alignment into a window into a complete worldview. It affirms the scientific rigor now underpinning these investigations, ensuring that the celestial masterpieces we celebrate are not products of our own wishful thinking, but genuine testaments to the observational genius of our ancestors. The challenge of preserving a 26,000-year celestial cycle within a single human lifetime seems insurmountable. Yet ancient cultures achieved this impossible task not with hard drives, but with the most resilient technology ever devised, the human voice. They turned complex astronomy into epic stories, transforming data into drama to be remembered and retold. This was the power of oral tradition, a sophisticated system for encoding cosmic knowledge into the very fabric of culture. Across the Indo-European world, from the Vikings to the Vedic poets of India, a strikingly similar myth appears. It is the story of a great cosmic mill, or a world axle, that grinds slowly through the ages. Scholars like Dr. Miriam Robbins-Dexter argue this was no random fantasy. The mill is a powerful metaphor for the precession of the equinoxes, the slow wobble of Earth's axis that causes the positions of the stars to shift over a cycle of 26,000 years. The turning of this celestial mill, often said to produce the salt of the sea or the flower of the land, perfectly captures the gradual, grinding nature of this vast astronomical process. These myths were not just for entertainment, they were meticulously crafted mnemonic devices. The rhythm of a song, the structure of a story, the sequence of a ritual, all served as cognitive scaffolding. This framework allowed a keeper of knowledge to memorize and recall immense amounts of information with flawless accuracy. A single chant could contain the entire rising and setting patterns of key stars for generations. A hero's journey might encode the complex 18.6-year lunar cycle. The story itself became the storage device, and the community became the living library, ensuring its survival through countless retellings. This represents a feat of cultural memory that our modern society, so dependent on external and fragile digital storage, has almost entirely lost. we have outsourced our remembering. They internalized it, weaving the cosmos into their identity. Their knowledge was not stored, it was lived. It was sung at births, recounted at gatherings, and performed under the very stars it described, creating an unbroken chain of wisdom that connected each new generation directly to the first sky watchers who began the observation millennia before. The true genius of these ancient astronomers is revealed not in what they lacked, but in the elegant tools they created from the world around them. Without telescopes or metal, they engineered a sophisticated toolkit for measuring the heavens. Across Europe, artifacts known as calendar sticks have been discovered. These are bones or pieces of wood with a series of carefully carved notches. At first glance, they appear simple, but analysis shows these markings often correspond to lunar cycles, tracking the phases of the moon with remarkable accuracy. This was a portable, personal calendar, a way to hold time in one's hands. Far to the north, a more complex device emerged from the Viking Age. The Hōkūleʻa disc, found in Greenland, is a wooden artifact with carved lines and a central gnomon, or pin. Researchers believe it functioned as a sun compass, allowing Norse sailors to navigate the treacherous North Atlantic by using the sun's shadow, even during the long twilight hours of the Arctic summer. This was not a child's toy. It was a precision instrument for wayfinding in a world of ice and ocean, but some of their most profound tools were not handheld at all. They were built directly into the landscape. Imagine a still, dark pool of water sheltered from the wind. For an ancient sky watcher, this pool became a perfect artificial horizon. By observing a star's reflection in the water as it first appeared over the real horizon, they could pinpoint its rising with far greater precision than the naked eye alone allowed. This simple method transformed a puddle into a sophisticated observational tool. The ultimate expression of this architectural astronomy is found in the great passage tombs like Newgrange in Ireland. Here, a long, stone-lined tunnel, dark and silent all year, was engineered with one spectacular purpose. For just a few minutes at dawn on the winter solstice, a single, narrow beam of sunlight pierces a special opening above the entrance, traveling down the passage to illuminate the inner chamber in a dramatic burst of light. This was not an accident. It was a feat of engineering and celestial understanding, a way to capture the sun itself on the year's shortest day. These tools, from the notched bone to the sunlit chamber, demonstrate that the key to their success was not advanced technology, but profound ingenuity. They used water, stone, and shadow to solve problems of celestial measurement, proving that the most powerful instrument was, and always has been, the human mind. Yet the sophistication of these ancient tools pales before a single bronze object, unearthed not by archaeologists but by looters on a German hilltop. The Nebra Sky Disc, cast around 1,600 years before the Common Era, is the oldest known concrete map of the cosmos in the world. Its surface of deep blue-green patina is inlaid with golden symbols that are not random decorations, but a precise and functional astronomical guide. A cluster of 7 stars is almost certainly the Pleiades, a star group of immense importance to ancient farmers for marking the planting and harvest seasons. A large golden circle and a crescent are understood to be the sun and the moon, but the disk reveals even deeper layers of knowledge. Along its rim, 2 golden arcs were later added. Their precise angles capture the range of the sun's travel along the horizon between the summer and winter solstices. This was not just a picture, it was a calculator, a device to measure the year's most critical turning points. Perhaps the most mysterious symbol is a final addition, a graceful golden arc along the bottom, often called the sun boat. This image does not come from local European mythology, but seems to be a direct import from the ancient Near East, a vessel that carried the sun through the underworld each night. This single detail transforms the disk from a local artifact into a document of international thought. Scientific analysis confirmed this astonishing connection. The gold used in the disk was traced through its chemical fingerprint all the way to Cornwall in southern England. The copper for the bronze came from the Austrian Alps. The Nebra Sky Disc is therefore physical proof of a Bronze Age network that traded not only in precious metals, but in profound ideas. It is a stunning synthesis of art, science, and spirituality, a portable cosmos that served as both a religious icon and a practical tool for tracking time. This object represents a unified cosmological understanding, a shared vision of the heavens that connected the British Isles to the heart of Europe and beyond, revealing a continent already speaking the common language of the stars. This cosmic knowledge was more than intellectual achievement. It was a profound source of psychological power. To predict the sun's return on the shortest day of the year, or to announce the coming of the monsoon rains long before the first cloud appeared, was to wield an influence that must have seemed divine. In an unpredictable world, the individual who could read the celestial script held the ultimate authority. This gave rise to the Astronomer Priest, a figure who stood as the crucial intermediary between the community and the gods of the sky. Their ability to forecast an eclipse or the heliacal rising of Sirius, the star that signaled the Nile's flood in ancient Egypt, would have been perceived not as science but as pure magic. This was not deception, it was the natural outcome of a worldview where the heavens were alive with intention. The person who could anticipate the movements of these celestial beings held the well-being of the entire society in their hands. This knowledge inevitably created social hierarchies, the ruling class, often embodying or employing these skilled sky watchers, solidified their power by demonstrating a unique connection to the cosmic order. Their predictions govern the most vital rhythms of life, dictating when to plant, when to harvest, and when to hold the most sacred ceremonies. This created a stabilizing force for early agricultural societies. A community that could trust in a predictable cosmic calendar was a community that could plan, store surplus food, and grow in population and complexity. It provided a deeply comforting sense of order in a universe that could otherwise seem random and threatening. Beyond mere control, this shared cosmic narrative became a powerful tool for social cohesion. When an entire people gathers to watch the sunrise align with a sacred stone on the solstice, they are not just observing an astronomical event. They are participating in a story that reaffirms their collective identity and their place within a grand, meaningful design. The sky became the one unifying roof under which everyone lived, and the ones who could interpret its messages wove the community together with threads of shared wonder and celestial certainty. The authority of the Astronomer Priest was rooted in a promise of predictability, but what happens when the cosmos itself becomes unpredictable? A deep and recurring theme echoes through the world's oldest stories, a memory of a time when the sky fell. From the Mesopotamian epic of Gilgamesh to the flood narratives of the Maya and the fiery destruction described in Aboriginal Dreamtime, cultures with no possible contact share a startlingly similar story of a great cataclysm. For a long time, these were dismissed as mere allegory, but a compelling scientific theory suggests they might be a fragmented record of a real and devastating event. The Younger Dryas impact hypothesis proposes that around 12,800 years ago, fragments of a large comet entered Earth's atmosphere, striking multiple locations across the globe. The immediate effects would have been apocalyptic, with immense heat and shockwaves ripping across continents. The long-term consequence was a sudden, dramatic climate shift, a 1,000-year winter that reversed a period of warming and plunged the planet back into Ice Age conditions. This was not a slow change. It was a geological instant that would have reshaped the entire world that early humans knew. The trauma of such an event, arriving without warning from the heavens, would have been seared into the collective memory of the survivors. It presents a powerful and pragmatic motive for humanity's sudden, intense focus on the stars. The drive to understand the cosmos may have been born from a simple, desperate need. Never again, they needed to ensure that such a disaster would never catch them unprepared a second time. The sky, once a source of wonder, became a source of potential peril that had to be monitored, understood, and predicted. This transforms our understanding of ancient myths. They were not just fanciful stories, they were urgent survival guides encoded with the most critical lesson of all. The heavens hold both the promise of order and the threat of chaos, and our survival depends on knowing the difference. This collective trauma, preserved in story and song, could have been the catalyst that turned humanity's gaze upward with a new, unwavering intensity, forging fear into a disciplined and relentless pursuit of knowledge. The Antikythera Mechanism was discovered as a corroded lump of bronze amidst the statues and pottery of an ancient shipwreck. For decades, it was a museum curiosity, its true nature hidden under the crust of 2,000 years at the bottom of the sea. But when researchers finally peered inside using advanced imaging, they found not a solid block, but a complex clockwork of interlocking bronze gears. This was not a simple ornament. It was an analog computer of breathtaking sophistication, designed to predict the movements of the sun, the moon, and the known planets. By turning a hand crank, an ancient user could calculate lunar phases, forecast eclipses, and even track the cycle of the ancient Olympic Games. Its dials and pointers presented a mechanical simulation of the heavens themselves, a miniature cosmos driven by precision engineering. This single device, built around the 2nd century before the Common Era, shatters our timeline for technological progress. It proves that the Greeks, and perhaps other cultures, were constructing machines of a complexity that would not be seen again until the mechanical clocks of medieval Europe over 1,000 years later. The Antikythera Mechanism stands as a stark, physical reminder that advanced knowledge can be lost, that a single shipwreck can silence an entire school of thought for centuries. It forces a humbling question: how many other such devices were built only to decay into unrecognizable fragments, leaving no trace in the historical record? This artifact is not alone in its mystery. Other objects, like the so-called Baghdad Battery, a clay jar from 2,000 years ago containing a copper cylinder and an iron rod, suggest experiments with electroplating. The Viking Unartok disc, as we have seen, was a sophisticated sun compass for navigating the open ocean. While some of these finds are hotly debated, and many have simpler explanations than first supposed, their collective presence is deeply significant. They are anomalies, pieces that do not fit neatly into our established puzzle of the past. Each one whispers the same unsettling possibility. What we consider the peak of ancient technology might only be the scattered, surviving foundation of a much higher summit that has since crumbled away. The collapse of Bronze Age trade networks, the burning of libraries like Alexandria, the slow fading of oral traditions, any of these could have severed the thread of knowledge. The mastery of the stars, so evident in stone and story, may have also found expression in intricate machines of brass and bronze, most of which returned to the Earth, leaving behind only a single, miraculous survivor to challenge all our assumptions. The word primitive carries a heavy and unexamined weight. For centuries, it was used to describe societies without written records, implying a simpler, less developed form of human life. Yet the very stones we have been discussing stand in silent, absolute defiance of that term. The precise celestial alignments at Göbekli Tepe, the continent-wide mathematical system of the megalith builders, the vast mental star charts of the Polynesian navigators, none of these are the products of a simple mind. They are the fruits of intense intellectual labor, the result of a cognitive modernity fully equal to our own. This evidence demands more than a simple update to our historical timeline. It requires an ethical reckoning with how we have chosen to tell the story of humanity. The colonial mindset that labeled these cultures as primitive was not a neutral observation. It was a tool of power, a way to justify domination by placing entire branches of the human family on a lower rung of an imaginary ladder of progress. To now recognize the profound astronomical science mastered by these societies is an act of historical justice. It restores their rightful place as pioneers of human thought. This shifts the very definition of progress away from a checklist of technologies like writing and metallurgy and toward the deeper capacity for abstract thought, long-term observation, and the creation of complex systems of knowledge. Human intellect did not suddenly emerge with the first written word in Sumer. It had already been flourishing for millennia, encoded not in clay tablets but in stone circles, in epic oral poetry, and in the very patterns of daily life synchronized with the cosmos. Acknowledging this diverse legacy is a crucial step in decolonizing our past. It allows us to appreciate the many unique paths our species has taken in its quest to understand the universe. The story of human knowledge is not a single straight line leading to the present. It is a vast branching tree, and by honoring these forgotten astronomers, we do more than correct a historical error. We enrich our shared human heritage, finally giving voice to the countless generations who first learned to read the stars. The tools of modern astrophysics are now turning ancient star maps into testable data. With planetarium software like Stellarium, we can wind back the cosmic clock to any moment in deep history, recreating the exact sky that would have hung over a place like Stonehenge on a solstice night 4,500 years ago. This digital time machine allows for a level of verification that was once impossible. Researchers can input the precise coordinates and date, and the software renders the celestial dome with flawless accuracy. The result is often a stunning confirmation. An alignment that seemed speculative is revealed as a perfect match between a standing stone and a star's rising point, proving intentional design beyond any reasonable doubt. This technological validation bridges millennia, connecting the intuition of the ancients with the computational power of the present. It affirms that they were not merely storytellers, but meticulous observers whose records, encoded in architecture, hold up to rigorous scientific scrutiny. This convergence extends beyond simple alignments into the very rhythms of our planet. The study of solar cycles, once the sacred duty of priests who tracked the dimming of the sun through ceremonial observation, is now the foundation of modern heliophysics and climatology. We now understand that the sun has an 11-year activity cycle marked by sunspots and solar flares, which can influence Earth's climate in subtle but measurable ways. Ancient sky watchers, noting patterns in weather, animal behavior, and crop yields, may have been correlating these earthly changes with long-term solar variations they could see with the naked eye. Their mythologies of a sun god growing weak or strong could have been their way of modeling a complex natural process. This means the data points they gathered, preserved not in spreadsheets but in stone circles and oral traditions, represent a long-term environmental record. Their observations of celestial patterns and terrestrial outcomes form a valuable dataset that spans centuries, offering a unique perspective on climate variability that our short-term instrumental records cannot provide. This partnership between past and present reveals a profound truth. Those early astronomers were practicing a form of empirical science. They observed the world, formed hypotheses about the connection between the heavens and the earth and encoded their conclusions into a durable cultural format. We are only now developing the tools to fully appreciate the depth of their inquiry, discovering that their wisdom still has something to teach us about the long, slow cycles of the cosmos we all call home. The hidden cities emerging from the jungle canopy are rewriting our maps of the ancient world. In regions once considered impenetrable wilderness, like the Amazon basin and the dense rainforests of Central America, LIDAR technology is peeling back the layers of vegetation to reveal the ghostly footprints of vast urban centers. This laser scanning from the air creates a three-dimensional map of the true ground surface, exposing enormous earthworks and ceremonial platforms that have been invisible for centuries. The true revelation is not just their size, but their orientation. These sprawling plazas and causeways are not arranged randomly. They are deliberately aligned with the solstice sun or the rising of key stars like Venus, proving that the celestial religion of the Americas was far more widespread and sophisticated than we ever knew. This technology is allowing us to see the forest for the cities, uncovering a lost world of urban planning rooted in cosmic order. Alongside this new vision of the landscape, a new kind of vision is scanning the old one. Artificial intelligence is now being trained to analyze the precise orientation of thousands of known archaeological sites, from stone circles to temple foundations. The human brain is brilliant at spotting patterns, but it is also easily distracted by compelling stories. An AI has no such bias. It can coldly process immense datasets, searching for statistically significant clusters of alignments that point to a shared astronomical tradition across continents and millennia. This digital assistant can identify a common focus on the star Sirius, for example, or a widespread understanding of the lunar standstill cycle, patterns that were previously too subtle and widespread for any single researcher to ever confirm. This moves the field from the analysis of single, spectacular sites to the understanding of entire intellectual systems, revealing the true scale of our ancestors' celestial obsession. The promise of these tools points to a future where the very timeline of human history may stretch and reshape itself. As LIDAR scans the remaining unexplored regions of the globe and AI sifts through the data of every known monument, we stand on the verge of discoveries that could push the origins of advanced astronomy back by thousands of years. The next decade may well reveal an observatory built by the first humans to cross into the Americas, or a temple complex in Southeast Asia that predates anything we have yet imagined. Each new find has the potential to rewrite the story of human migration, cultural exchange, and our innate drive to comprehend the cosmos. The silent conversation with the Star Masters is only just beginning, and after millennia of silence, we are finally learning how to listen. This grand synthesis of evidence points to a single, unifying truth. The drive to map the heavens is not a luxury of settled civilization, but a foundational trait of our species, as intrinsic to us as language or tool-making. From the moment the first human looked up and recognized a pattern in the scattered lights, a great project began. It was this cosmic quest, stretching back tens of thousands of years, that actively shaped the very fabric of society. The need to observe the stars demanded stable, long-term communities like those at Göbekli Tepe, capable of preserving knowledge across generations. This celestial focus spurred technological innovation, leading to the precise engineering of the megalithic yard, the ingenious design of the Polynesian star compass, and the complex urban planning of Cahokia. Our spirituality was forged under that same celestial dome, with myths and rituals emerging as the primary tools for encoding and transmitting this hard-won astronomical data. This completely redefines the starting point of history itself. We have long marked its beginning with the invention of writing, a mere 5,000 years ago. But the true dawn of history, of our collective intellectual journey, occurred far earlier. It happened in the silent, patient observations of the first sky watchers, individuals who began a conversation with the cosmos that we are still continuing today. Our entire past can now be seen not as a slow crawl from primitivism, but as a continuous, purposeful exploration. This reframes every ancient monument not as a mysterious relic, but as a chapter in a single, grand story. It is the story of humanity's enduring cosmic quest, a legacy written in stone and star that connects us directly to the very first ancestors who dared to understand the universe. This journey through time and stone reveals a single, unifying truth. The mastery of the stars was not a pinnacle reached by a few isolated cultures, but a foundational thread woven into the very fabric of our shared prehistory. From the hunter-gatherer architects of Göbekli Tepe to the intrepid voyagers who conquered the Pacific, our ancestors shared a profound and deeply practical relationship with the cosmos. This was not abstract philosophy. It was a living science that guided their migrations, dictated their harvests, and gave meaning to their existence, shaping their worlds in both stone and story. This collective inheritance stands as a powerful challenge to our modern assumptions of superiority. It reconnects us with a lost heritage of intellectual brilliance, reminding us that human genius flourished long before the written word. The night sky above you is the same cosmic canvas they studied with such dedication. It is an invitation to look upward with new eyes, to see beyond the scattered lights to the immense legacy they represent. See it as they did, as a universal map, a celestial clock, and an ancient storybook filled with the wisdom of countless generations. We would love to hear which of these star masters from our deep past resonates most with you. Was it the megalithic engineers, the Polynesian navigators, or the unknown astronomers of the Sahara? Share your thoughts in the comments and subscribe to join us as we continue exploring the great mysteries of our past.